Hello everyone, welcome back to another lesson. And in this lesson we're going to see how we can utilize Sigma rules in order to get some inspiration and ideas for our detections. So I went on ahead and typed in the Sigma rules into Google, into the search. And we can see that we have a GitHub repository here, which is an open source repository for Sigma. And basically, if you guys don't know what Sigma is, it's some sort of a markup language, a tagging language that can be translated between different sim systems. And it's like an open source specification schema for detection rules. So we can see some examples here and implement them to our deployment. But before we do that, I want to be more focused about the detection I want to show you, which is a research that the Japanese CERT created a while ago. And you can find it by typing Windows commands abused by attackers. As you can see, we are the Japanese CERT website. And they released a research that specifies the top 10 commands that attackers run on systems that they manage to get access to. So I want to use, first of all, this example, and then we'll move on to the Sigma examples. And we can see that there's 10 commands here. A lot of them are noisy and require further fine-tuning, but let's go ahead and see what we can get from this. Okay, so the first thing I want to say before we do this is QRadar has a functionality called event coalescing, right? And I will go more in depth about this topic in later parts of the video, but we have to take care of this now in order for our detections to work. And event coalescing is basically a functionality that allows QRadar to group similar events to the same line, to the same event here. So as you can see, I have the event name that a new process has been created, but the event count is 11. So what does this mean is that all of those 11 events have similar characteristics, and it goes by the source IP, it goes by the port, the username, and if all of those match within a very short amount of time, it's going to group all of those events into one event. Now, for some log sources, it does make sense to enable this functionality, but for our Windows endpoint, it doesn't really make sense because we want to have each event in its own separate file, because the command line, which is this field, is going to be different, and we will not be able to see the full command line for each event. So for example, if I go ahead and type who am I in my command line, it's going to group it under the same event with many other different events, and that's kind of not going to work out for us. So in order to cancel this, what we need to go to the admin tab and go into our log sources, find the log source that we want to modify, which is our Windows endpoint, go into edit and scroll down here until you see coalescing events, right? So you need to turn this off, hit save. And now basically what happens is that each process created event and every other event that is arriving from this log source is going to have its own separate line with an event count of 1. So let me go ahead and open my command line. I'm going to type in a few whoami's here so we can see. And it's going to take a few moments here to arrive to our deployment. And we can see that it's been a minute since the last event and the coalescing is still active. So I'm going to pause the video here for a few moments until this kicks in, and I'll see you guys soon. Okay, guys, welcome back. And as we can see, the coalescing has cancelled, and now each event is arriving with its own event count and its own unique properties. So let's go ahead and enter one of those. I'm trying to find my whoami command. And it seems like it did not arrive yet. Let's try again. A few more. Okay, so let's give it a few extra moments. But meanwhile, what I want to talk about is specifically a new process has been created is one of the most important telemetry sources that you can extract from your Windows endpoints. They all have the same event ID of 4688, right? And the reason why this is so important is because this event ID includes the command line arguments that the attacker might add to the command itself. So this is not enabled by default. You have to go to your group policy settings to enable it, but a quick search online will tell you how to do it. So if you wouldn't have this enabled, what you're going to see is basically just this part right here. You're not going to see the additional command line arguments that are being sent with it, which is, of course, the main indicator of attack that we are looking for. So we have a few more of process created here. Let's try to find who am I. Okay, so instead of looking one by one, what we can do is go back to our event list and click search, edit the search, and we can sort by custom properties, right? So I'm going to go ahead to column definition, and I'm going to type in command. And I'm going to click this add column button here. And you can see that it's now going to group by the command property. And under columns, we can remove columns that we don't want. So if, for example, I don't want to display the category, I can delete it. I don't want the destination and source port, the magnitude, I can delete those. And if we hit search now, it's going to display our events aggregated by the command without the columns that we removed. So we can slide this open right here, and we can see all of the commands that we have. And I also see that my whoami command is being shown here. So let me open up this page. Okay, so whoami command is very important when we are dealing with attackers because it basically allows them to know what is the station that they arrive at. And most of the time they're going to use this command. By itself, it's not completely suspicious. It can be done by the IT people or a sysadmin who's doing some tests, but it is useful to pay attention to it. So we can see that our detection, that our whoami commands are being sent to QRadar. And now what we want to do is basically create a new detection in order to match for those occurrences. So what I'm going to do here, let's say I want to track whoami, I want to track task list, and I want to track system info, all in one detection. So we have multiple ways of doing it, right? Let's go back to our use case manager and create a new detection. And like we said in the previous videos, we can use our building block in order to track only Windows events, right? Go ahead and add our building block. And now we have multiple choices. I'm going to show you both. So I'm going to add a search filter. So the first method of doing this is by using the command filter, right? Because this is the property that we are looking for. So we can go ahead and add that to the filters, and let's make sure to not use equals any of, but contains any of, because we can't be sure 100% of the time about the case sensitivity of the text. So let's go ahead and use contains. Let's go ahead and add who am I. Let's go ahead and add task list. And the third one, system info. Go ahead and add system info. And hit add. And what we've done basically is we're saying we applied multiple searches into one property, and now we're saying that if command contains any of the following, who am I, task list, or system info, basically trigger my detection. So this is how it looks. Now, in addition to this, I would like to add a filter in order to track down only process created events, right? Because by using this building block, we are only tracking Windows events, but there are many, many different kinds of Windows events. So, and again, we can use either the QID because we know that we're being very specific only to one type of event, or we can use one of the custom properties in the event itself. So I'm going to choose to do that. It doesn't really matter. So as you can see, 4688 falls under event ID, right? So I'm going to go ahead and event ID, right? And we need to make sure it's custom, although it doesn't matter because if we go back to the event itself, there are some built-in properties, right? So if we scroll down here, we can see that event ID without custom is the same value. So we can use either, it doesn't really matter, okay? So let me go ahead and type event ID, it's fine. And here we can use equals any of because it doesn't matter about case sensitivity. I'm going to do 4688. Add and submit. And now basically we have a very decent detection to track those three commands, which can be malicious. So let's go ahead and call this potential Windows enumeration detected process created. I'm gonna go ahead and copy the name. And let's index our events by command, right? Because this is our most important field that we're tracking, and we want to see this kind of like the main field that the detection is trying to track. I'm going to go ahead, dispatch a new event, like we've seen in the previous examples. Not going to change any of the categories, right? Those categories, I don't prefer to change them because they are the categories that the custom rule engine event is going to have, and I'm not paying too much attention to the custom rule engine event, so I'm just leaving them as default values. So I'm going to go ahead and enable the rule. Now, the reason I'm indexing by command, right, is because we want each command to have its own offense. So if I type who am I, and then I type task list, and then I type system info, I want each of those attempts to trigger their own offense. This is why we index by command, so that each command gets its own dedicated offense. So if you're going to go ahead and enable this rule, let's go back to our offenses. I'm going to type in, open my command prompt, and let's go ahead and type who am I. And let's go ahead and type system info. Right. And load. And let's go ahead and type in the third one, task list, right? Type that. Okay. So I'm going to pause the video here again, give it a few moments, and in a bit we should see 3 offenses being populated. So I will see you guys in a bit. All right, everyone, welcome back. And as we can see, we have our 3 offenses. And the offense source, we can see the commands that we typed. So this is very useful detection for SOC environments, for basically every kind of organizations. It's like a universal detection. Almost everyone is using it. And let's assume that we want to exclude some parameters, right? Because this can get very noisy very quickly. Let's go ahead back to our use case manager. Let's do a refresh here. Right, so I can go ahead and I can exclude by username, I can exclude by source IP, whatever parameter that you want. So if we want to exclude source IP, I would go ahead and type source IP, add the test, and I would change the end right here to end not when the source IP is one of the following, right? And I would go ahead and type in my address. And you can add multiple values. As many as you want. You can also add CIDR ranges, so I can do 133.0/24. And if any of the source IP is going to be one of those addresses, it's not going to trigger, right? So this is very useful. And another tip I recommend doing is grouping all of your exclusions in a separate building block and then use that one. Because then you can edit it in one place instead of changing all of your detections one by one. So I can also go ahead and type filter, change this to end not, and then I can filter by username or any other property that's available to me. And for example, contains any of test or whatever that we want. Hit submit, and now every event that has any variation of test is going to be excluded as well. So in later videos, we're going to see how we can add custom properties that are not parsed by default by QRadar. So this would be our example based on the Japanese CERT use case. And let's go ahead and talk about the Sigma examples, right? Let's go ahead back to our repository. And I'm going to go ahead and enter the rules directory. Windows. And as you can see, there's many folders here. But for our example, I'm going to choose again process creation. And you have a lot of files here, right? More than 1,000 files. And as you can see, they are all YML files, which is a markup language. And let's go ahead and choose any one in random. Maybe they have something about CURL. Yep. Go ahead and check out this one. So as we can see, all of our Sigma rules that we're going to take a look at, they have basically the same format, right? They have the title, they have their ID, references, description, tags, and the log source. So as we can see, the log source specifies basically from which telemetry source we can extract this kind of detection. So the product is Windows and the category is process creation, like we've seen. which are event IDs 4688. You can also extract from sysmon. And then we have the detection itself. And under it, we have the selection, which is basically the filter that we're going to hunt for. So in this current case, it tells us if the command line contains all of those values, not any of those values, but all of those values, then trigger an alert, right? Because we have a condition, and the condition is selection. And you can add Boolean operators like and not and such like this. You can add a filter. So if I go ahead and copy this, right, for just to show you guys, I can go ahead and type in filter, and then whatever my filter is, and then I can do selection and not filter. And if I want to exclude some addresses or properties, we can do that like this. So let's go ahead and see how we can translate this Sigma rule to a QRadar detection. So let's go back to our use case manager and create a new detection. So like the previous one, we're going to use our building block. And filter for only process created events. And now we're going to filter on command contains all of, not any of, all of. Let's go ahead and see what we have here. We have a space /c. We have CURL. We have HTTP. We have -O. And an ampersand sign, which is Shift 7 on the keyboard. Let's go ahead and add all of those. And we can see that the detection is going to trigger if command contains all of the following, right? Let's give it a name, CURL. Actually, let's just go ahead and copy this name. Title from here, paste it here. Let's index by command as well. Let's go ahead and run it. Now, I'm going to go ahead into my command prompt and I'm going to type a command that would trigger our offense. So let's go ahead and do CURL space C HTTP -O ampersand. It doesn't have to actually do anything, but we do want all of those filters, all of those characters to be present in our command line. I'm going to go ahead and press enter. As you can see, we didn't type the command correctly, but it does not matter because in a few moments here, the offense is going to trigger. I'm going to pause the video for a few seconds and resume once I see it. Okay guys, welcome back. So it seems I have made a slight error, but this is a good opportunity to show you some common issues when creating detections. So it seems that if I open up the event that has the CURL command in it, we can see that it is not being parsed completely, right? And if we scroll down to the process command line, we can see that it's missing the ampersand character. So I guess there's some parsing issue on Windows side based on those, so the character doesn't even register on the command. But we can see that the rest of the characters are here, right? So let's just go ahead and modify our detection and remove the ampersand detection. And unfortunately, we do have to rewrite the search again. There's currently no option to edit an existing filter. HTTP, let's do -o, and let's do space. Actually, let's do just /c space. Move this one, add this one, hit finish, and let's go ahead and type in the command again. And now it's actually doing something interesting. But yeah, I'm gonna pause again and resume once the offense triggers. Alright guys, welcome back. And it seems we have another issue, which is actually good because I can show you basically more things that you might bump into while configuring your detections. So it seems like there's an issue in parsing that occurs with the default parsing. And the way that we can actually take a look into it is if you go back to the event list and we see this is our event with a CRL command. And again, there's a dedicated section in the course for those types of things, but as a quick fix, I'm gonna quickly show you what we can do in this scenario. Is you go ahead and right click and view in DSM editor. And the DSM editor, it's like your parsing location. This is currently set on log source type Windows security event log, which is our log source type. And here we can see all of the custom properties and the default properties that are being parsed by this log source type. So let's go ahead and click on command. And as you can see, it displays a regular expression which will run on the entire log and try to match something. And as you can see, it's currently matching only CRL. And this is not what we want. We want to match the entire command. So the way we can fix this is by changing the parsing to match everything between process command line up to the word token, right? Because the word token will always be present after process command line. So let's go ahead and click edit here, delete the current parsing, and I've prepared a regular expression statement. You don't really need to know regex on a good level. You can just copy it from online searches, but I will explain how this command operates, right? So first of all, we're telling it, let's find this string, and then a colon, and then any amount of space, and then match for anything, right, in the parentheses here, match for anything until you see the word token. And the reason we have another any amount of spaces here is because between token and the command, we have a few spaces here, so we don't want to catch those. And as you can see, after I'm typing this regex, it marks the command that I want to catch in orange, which means that our parsing now should work the way we expect it to work. So let's go ahead and click OK. And we can also see in the preview here that the command is being matched exactly as we want it. So let's go ahead and save, close the window, and run the command again. And now our offense should trigger. So I'm going to pause here again, hopefully for the last time, and I'll see you guys in a bit. Okay guys, welcome back. And as you can see, our detection is successfully triggered. And if you go ahead to the event itself, we can see that the command line is now being parsed correctly. And again, there's a dedicated section for parsing and custom properties in later parts of the course, but because we've had unexpected issues with the default parsing, I wanted to take that opportunity and show you what can we do in a pinch situation like this. So the offense triggered successfully, and we've seen an example how we can translate Sigma rules into detections for QRadar. So I hope you guys enjoyed this video, and I will see you in the next one.